Welcome back. In this video, we will be going over the rain simulation in Houdini. By now, you should already have Houdini and your base file or terrain ready to go. So let's start by opening up a new file. To import your file, just go to File, Import, and Geometry. Once that has imported, it should show up in your network pane. Just to keep everything organized, I'm just going to rename this file to Terrain. Then I'm just going to add another geometry node by right-clicking or hitting Tab. And I'm just going to rename that to Sim. So this will be our simulation network. Now when we double-click the Sim node, we can start making our network. To start, we're just going to add a grid. This should show up in the scene view. Since my terrain is really big, I also need to change the size of the grid. So I can just make this bigger in the parameter pane and I'll just check the size in the top view. Now I'm just going to pull up the grid so that it's above my terrain. This is where our water particles will be coming from, so just make sure it's not too far away. So now we're going to add a pop net and connect the grid into the first input. You should be able to see the particles in the grid now. Next, we're going to do the networking in the PopNet. So if you double click on that node, this is the current network that comes with the PopNet. If you click on the source first input, we just want to turn off the guide so it's just the particle without the grid. Next, we want to check the birth rate under the birth tab. So the constant birth rate is set at 5,000. This is the number of particles it will generate every second. You can change that if you want, but I wouldn't go past 10,000 just because your computer might struggle with that. So I'm just going to leave it at 5,000 for this tutorial. If you play that now, you can see the particles generating, but they're not falling because we need to add in gravity. So just hit Tab again to add in gravity, and this will go between the pop solver and the output. So now when you play it, the particles should now start falling. So now we need to make those particles collide with the terrain. First, we're going to add a merge node, and that will go between the pop solver and gravity. Next, we're going to add a static object node and just join that into the merge node. But we want the static object to be on the left side and the pop solver on the right. So we're going to go into merge and just reorganize the inputs. And just make sure that the affected relationship is left inputs affect right inputs. Now we can go into static object and assign the terrain. So you just click this button here and pick the terrain or your base file from the layers. We still need to fix some of the collisions, so just go to the collisions tab, RBD solver, volume, and just check the collisions guide. just to make that a bit higher res, you can increase the uniform divisions. Also make sure that display geometry is checked. And we can also have a look at the physical tab. So these particles are resembling rain, so we don't want them to bounce, so let's change that to 0. And we also want the particles to run down the terrain, so we'll also change the friction to 0. So now we can play this and see what happens. If you're using a terrain made in Houdini and the particles are still not colliding like this, you actually need to turn this into a terrain object because we made this with a height field map. So just go to your shelf, add in the collisions tab, select your terrain and just go to terrain object, and now it should be colliding. If your base file has been imported from somewhere else and the particles aren't colliding, then you need to turn them into a static object. So in the same collisions shelf, you can turn your base file into a static object. So the collisions are looking good, but you may have noticed that the particles are falling down in layers. So we want to mix that up so it looks a bit more realistic. To do that, we are going to go back to the PopNet node and change the substeps to 6. So now when we have a look, the particles are coming down in 6 layers instead of just 1. So now we want to see the collision effect more clearly, and to do that we need to add a pop collision behavior node between the source first input and the wire pops. And I'm just going to change the group name to hit and preserve group. So now when we play this again, the particles will turn red when it collides with the terrain. We can also add a wind element to the particles to make it look more like rain. So under the pop collisions behavior, we're just going to add a pop wrangle node and type in the expression @bounce equals 1 semicolon. Next, we're going to put in a pop wind node under the pop wrangle. Now we can change the amplitude and swirl size to get the effect that we want. You can play around with this and just have a look at the different results you can get. You might also notice now that the particles are falling very slowly. We can change the wind velocity so that the wind is blowing the particles in the direction and speed that we want. Once you're happy with that, we're just going to add a pop group under the pop wind. I'm just going to rename the group name to Rain. So now our main rain simulation is done and it should look something like this. You can leave the simulation like this if you want. This is really good for drafting or testing out a model, but if you want to make the final model look nicer, then the next step is to focus more on the details of these collisions. First, we're going to add a second stream next to the main rain simulation. Rain usually leaves a trail of water behind, so in the next part we're going to create these trails after the collisions. So start off with a pop stream and change the source group to hit. And add a pop replicate underneath. In the replicate node, we're going to change the impulse count to 1, constant activation to 0, and the life expectancy to 0.05. Then under the shape tab, we're going to change that to point. And then under the attributes tab, the initial velocity will be changed to set initial velocity and then change the variance to 0.2. Next, we'll add a pop wrangle like before, but we're going to change the expression to 0 instead of 1. Then we'll add in a pop collision behavior node underneath, and I'll make the group name trail and check preserve group. Then we can add that into the wire pops. So when we play it now, you'll notice that the trail isn't there on the ground. Another pop stream needs to be generated through the control of the trail group. So we'll get this pop stream again, make the source group trail, join that into a pop replicate. Then we'll change the impulse count to 5 and life expectancy to 3. Add the pop wrangle and we'll keep the expression of 0. In the replicate, we'll set the initial velocity and change the variance to 0.1. Then under the shape tab, we'll change the uniform scale to 0.01. Next, we're going to add a pop property underneath the pop wrangle and change the cling to 100. Then we'll add a pop collision behavior and change the group name to slide particles. We can also change the color to maybe green, and then we'll join that into wire pops. So when you play it, the particles will leave a green trail. To make the trail slide along with the particles, we need to change the response in the pop collision behavior to slide. So now when we play it again, the trail should now be sliding. And that is all we need for the rain simulation. It should now be looking something like this. If you notice that your grid is bigger than your terrain and there are particles falling that aren't interacting with it, you can add in a pop kill that will just delete the particles once it reaches a certain point. So just add this in under the wire pops. Enable the bounding box and just change the size and height so it will catch all the stray particles. When you play it, you will see that the particles will automatically delete once it reaches the bounding box. Finally, we want to set up the view. So if you just go back to the main network pane, you can just add in a camera node. You can just move that around to get the right angle that you want. And you can also go back to that in the render scene. Next, we can also add in a light. This will give your scene a bit more contrast, especially if you have a rather flat terrain and everything blends in together. So you can also adjust the strength of the light in the parameters and also move that around to the spot that you want. Last thing I want to mention is the frames. So this bar at the bottom plays the simulations for you, but it's limited to a certain amount of frames. If you find that the video is a bit short and you want to show something that will happen later on, then you can change the start and end frames. If you put in too many frames for the video, then it will take a really long time for your computer to load. I would recommend not going over 300 frames. However, you can also change the start frame to start the video a bit later. Then you can film some of the later frames and then stitch it together with the earlier frames later in a video editor if you want. Now we can switch into the render view, and this is where you can select your camera and render the scene. Once that's done rendering, you can export that, and that is your rain simulation.